We were going to, we're gonna get the price of gOHM. All right, so I found the gOHM AVAX contract, so it was over here. I'm just gonna copy this address, put it in. Actually, put it down here. gOHM WaveX, and then we copy this down here. Here's the address. All right, cool. So we've got this, but this is going to give us the relative price of gOHM to AVAX. Another thing that we need is AVAX to some kind of stable coin. So that is something that I'm going to be doing right after this. So for now, I feel like we need to reuse some of the functionality that we have here. And I think that could be like really useful if we want to find out the price. Let's see. So we can get the ratio of the reserves, but it would be a little bit tough because depending on what kind of coins you are getting the reserves of, it might be a little bit tough to find. The only problem is with the decimals. So if both the coins have the same number of decimals and their price is pretty close to each other, let's say one coin has like a reserve of like 1,000 to 1,100. Depending on which coin you divide over the other, to get the relative price, it'll either give you like 0 or 1, because division with big numbers, it basically gets rid of the remainder, right? So because it's all int division. So I think one way to kind of get rid of that, that could be potentially useful, is to extract each token individually and then leave maybe like 5 or 6 significant digits, and then in that case we can with pretty good confidence divide each if each number has like 5 or 6 significant digits, then it'll after you divide them, it's going to be still accurate enough. It's not going to lose a lot of information throughout the process of division. Alright, so I think one thing that I'm going to do here is to create some kind of data class for the tokens that we're going to load. And I think I wasn't doing it so far because I didn't really see the need for it, but I feel like now we're at a point that it might actually be useful. So let's create a TypeScript file, token, ERC token, maybe. I already do have an ERC token. No, I only have ERC contract, so that's pretty good. ERC20 token. All right, cool. So we have this class. Let's name it ERC20 token. That's pretty good. Constructor, and then we've got address, which is a string. And then decimals, number. What else do we care about? There's name, string, symbol, string. And that's pretty much it. I don't really see anything else that would be super useful here. So this.name equals name. This.as name symbol. Alright. Let's copy paste this again, and then, whoops, symbol, decimals, let's copy paste that again, and then we're going to change that to address. Alright, cool. Export class, and this is good. Alright, so I wonder why this is complaining. It's probably because I haven't declared the same thing over here. Name, string, symbol, string, decimals, number, address, string. Alright, cool. So TypeScript is not complaining anymore. And I'm going to have another helper utility here. And I'm gonna name it toNumber. And what this does is that it gets a big, or number, or big int, or big number. Yeah, there we go. Nice. And then over here, what I'm going to do is return b dot. Okay, that's where we have to pretty much figure out what we're going to do. So I'm going to set up like a significant digits here. I think that'll be pretty useful. Let's see. So what if the only case where I would run into some kind of problem with that would be if the number of significant digits was less than the number of decimals. Sorry, more than the number of decimals. Then in that case, you can't really get that many significant digits. But I guess it's not that bad. Okay, let's do const significant digits, and let's say we want six significant digits. And then that pow utility function that we had here, pow, let's actually move it over here. I think that is more useful. So if we have a big number, one thing I'm going to do is I'm going to multiply it by a larger number, then divide it by the number of digits, then divide it by the same number but in number format, not big number format. So this is what I'm going to do, db.multiply, and then I can do pow significant digits, and then after I multiply it by that, I can divide it by the number of decimals that I have, and then I can call toNumber, and then I can divide it by math.pow. Whoops. Oh yeah, pow 10, and then we can have significant digits. All right, cool. So this should technically give me the correct number format with 6 significant digits, right? I guess we do want a from number here as well. So n is a simple number, and then we want to basically convert this number to a big number. However, that number should basically be, for example, if I'm sending 1 USDC, this should convert that 1 to 10 to the power of 18, because that's how many digits are in USDC, or sorry, decimals are in USDC. So let's see how we can do that. Big number dot from, and then what we can do here is probably, okay, so if this is a fraction number, then this is not gonna work. We should basically do something like math.pow. So let's get all of the decimals in, then we will multiply it by this number. And I'm guessing this is going to be actually interesting, because how can you do that? I'm guessing I can probably just use the significant digits here to get those number of ones kind of encoded in it. So let's see. Big number from, and then what I can do is do pow, and then significant digits. So we have this, or let's do it this way: number times math.pow. Why did it create a new line? 10 significant digits, right? And that's pretty good. And then multiply, oh yeah, now I figured it out. Multiply by pow this decimals, and then at the end, I'm gonna divide it by the same kind of upscaling factor that I did here. So div, and then I'm gonna have pow, significant. I think that'll pretty much, if you return this, and this returns a big number, and this returns a number, and that's pretty good. And now, I think one thing that makes sense is to, so once you load this ERC20 token, this is technically it's not wrapping every single individual, amount of ERC20 that we're working with, but it's a pretty nice helper class that helps us do, all the things that we want to do. So, and we can, and another nice thing about this is that this significant digits, we can change it to, I think, a pretty large number. Like, let me actually just change it to 9 for, just to be safe, so that we don't lose too much information. But conversion from big number to number is fairly safe, I think. But yeah, let's just try them out. I think that way we can figure out if there's any problems. So another thing that I want to do here is loading, like have a function that basically loads ERC20 contracts, and it also, I want to have a contract that does, sorry, I want to have a function that does not load the contract twice, or load the number of digits the token might have twice. So let's do it. Const token lookup is something like this, and then we can actually have a lookup from address of the token to the actual token class. So lookup ERC20 token, that's good. Export const load token, and then I'm gonna have C contract ish, and then what this does here is oh yeah, to declare it as a function like that. So what we're gonna do is to create pretty much the same get ERC contract function that I had here. Yeah, there we go. So const ERC contract is get ERC contract, and then I basically have this. I wonder if this, oh yeah, this is a contract dish too. Next. Awaits, and then we put an async here, so that we make it an async function. So we have the contract. Actually, this is not an async function. Yeah, it's not. Okay, I can basically just get rid of this. And then we have to create a new, basically, I guess, yeah, that's the contract, that's the token. Yeah, so we don't really have any naming clashes here. Const token equals new ERC20 token. And what's the first thing that we put? It's the address. So how do we look at the address here? Let's take a look at how they look at the address here. It's basically this way. So we pretty much have, I guess let's just change this to ID. That'll fix that. And then I can probably get address, yeah, from the address book. So if we pass in an address, it'll already take that one as address. If we pass in a contract ID, then it'll look up the address from the contract ID, and that'll give us the address that we want. So there we go, that's the address part. Whoops, address. And then we have await, and then we have the number of decimals, which is ERC contract decimals. All right, cool. And then we have await ERC contract name, and then next thing that we want to pass in a symbol. So we do that. ERC contract symbol. All right, that's our token. Awesome. And now at the same time, we want to basically see if token lookup address is not, I usually want to keep these type checks explicit. So if this is not undefined, then return it. All right, awesome. And if it is undefined, then we go ahead and fetch a token, and we do token lookup, and then address equals token, and then we can return the token itself. All right, awesome. Now let's actually try this part. The way that we do that is by going to balance page and kind of refactor our code and have it pretty much use some of these classes and functions that we've written here, which could be super useful. Also, I guess with the price lookup, we're going to have to do some extra stuff over there too. All right, cool. So here is when I was doing some debugging. So let's just get rid of all of that. So the way that we get the balances here is going to be fairly simple now because of all these functions that we've written. So we've got the coin. One thing that we can do is to basically do const token equals load token. It's an async function, so we do await load token coin. And then what else do we have? So that's pretty much, oh, interesting. So we load the contract, but at the same time, I want to get the balance of this thing. So I wonder if we can actually get it, like do it in a cool way. Maybe we can actually pass the actual token here too. So contract, and then we do contract. I think this is of type contract here. That pretty much comes from the ethers.js library, if I'm not wrong. Yeah, that's true. So that way I can just pass in the contract as the last thing here. Contract on. There we go. This dot contract equals contract. All right, awesome. So one thing that we can do now is pass in the ERC contract here as well. The really cool thing that this does is that you pretty much have the token, but now that you want to basically get the, for example, balance, because this is what we do. Let's just do const balance equals token from big. Huh, this is weird. Oh yeah, let's just do promise of ERC20 token. There we go. From number. I guess this is a better way. This should be from big number, and then this should be to big number, really, to big number. I just realized the naming of these functions were not correct. All right, so from big number, and then we do token or await token dot contract dot balance of, and then address, right? And that'll give us the balance, and then we can just do balances.push. So that just gets rid of all of those lines where we were dealing with the number of decimals and all that kind of stuff. Let's not do anything with the prices just yet. Let's figure out if this actually works properly. And if it does, then great. Yeah, it looks like it is working. Let's change it to, let's go to the actually network and change the network to Ethereum again to see, because over there we were having more. Let's go dismiss this. Alright, let's actually refresh everything here. Alright, start now. Alright, cool. So it looks like this account doesn't have anything. So let's just go on Etherscan and find some account that does. So Etherscan Olympus. Yeah, so let's go to someone who has some stake to own. I'm pretty sure we can even put the treasury itself to see like how much, for example, stake own the treasury owns right now. Let's just go here, holders. Oh, so the staking contract seems like that has the most amount of SO. Alright, other than that, let's go to, for example, this address. It has 94,000 stake only. So let's copy this contract from here. What was the address that we were passing here? It was here. Yeah, there we go. Alright, there we go. Promise rejection. Oh no. What else is going on again? Oh, interesting. This was a really cool corner case because it's actually giving us a overflow. Nice. This is good because it's a bug that we get to solve. So this address probably has too much. So when we, I guess, where we run into issues is where we call from big number. And that is where we kind of hit the wall. Alright, so when we do balance of, gives us this big number, and then once we do power map, like multiply by significant digits, and then we divide it by this dot decimals. Oh, okay, this makes sense, because this should not be divided by just the number of decimals. It should be tau of that, because that simply divides by 18. We want to divide it by 10 to the power of 18. And then if we do two number, yeah, that makes sense. All right, cool. Let's see what this did. All right, cool. So looks like this account has some ohm. This is actually a really good example. Has some staked ohm, but they don't have any gOHM. Most of their ohm is staked, however. Let's take a look at what the actual amount of ohm that they have, because I feel like this is not the correct amount that is showing up here. Let's go and there we go. It should have 94,769 staked ohm. Alright, looks like I'm gonna need to do some debugging. I'm just gonna go ahead and figure out what's wrong with this, and then I'll get back.